So, what's up?
This episode is sponsored by Front End Masters. They have a terrific lineup of live courses you can attend either online or in person. They also have a terrific backlog of courses you can watch, including JavaScript The Good Parts, Build Web Applications with Node.js, AngularJS in Depth, and Advanced JavaScript. You can go check them out at frontendmasters.com. This episode is sponsored by CodeShip.io. Don't you wish you could simply deploy your code every time your test passed? Wouldn't it be nice if it were tied into a nice continuous integration system? That's CodeShip. They run your code. If all your tests pass, they deploy your code automatically for fuss-free, continuous delivery. Check them out at CodeShip.io. Continuous delivery made simple. This episode is sponsored by Watch Me Code. Have you been looking for regular, high-quality video screencasts on building JavaScript done by someone who really understands JavaScript? Derek Bailey's videos cover many of the topics we talk about on JavaScript Jabber and are up on the latest tools and tricks you need to write great JavaScript. He also covers language fundamentals, so there's plenty for everybody. Looking over the catalog, I got really excited, and I can't wait to watch them all. Go check them out at javascriptjabber.com/watchmecode. This episode is sponsored by Component One, makers of Widgmo. If you need stunning UI elements or awesome graphs and charts, then go to widgmo.com and check them out. Hey everybody, and welcome to episode 120 of the JavaScript Jabber Show. This week on our panel we have Jameson Dance.
Hello, friends.
Aaron Frost.
Hello.
AJ O'Neill.
Yo, yo, yo. Coming at you live from San Mateo, California.
Joe Eames.
Hey there.
I'm Charles Max Wood from devchat.tv, and this week we have two special guests. We have Eric Bidelman.
Bidelman, hi.
Bidelman.
No problem. Asked. You're not the first one to get it wrong. It's
Beetlejuice.
Beetlejuice.
Yeah, Beetlejuice.
We also have Rob Dodson.
Yeah, hey, how's it going?
You guys want to introduce yourselves really quickly?
Yeah, so I'm Rob Dodson. I'm a developer advocate here at Google, and I work primarily on the Polymer project, helping to get Polymer in people's hands and also to help folks learn about web components and these cool new emerging standards.
Yeah, my name is Eric Bidelman. I've been at Google on our developer relations team now for almost a little over 6 years, and primarily focusing on HTML5 and working with Polymer and web components now. It's been my focus the last couple of years because I'm a web developer and I'm super excited about this stuff as a web developer, so I want to help other folks kind of get ramped up and start using it.
Awesome. So
That's awesome.
The show title says Google I.O. Are we talking about the conference or are we talking about something else?
We can talk about Google I.O. We can talk about web components. I mean, that's really Eric and I's sort of like field of expertise at the moment is Polymer and web components. So if you have questions about that, I think that'd be a good place to...
I'd love to talk about the Polymer stuff.
I was going to say, how about yes?
Okay.
Yes to everything.
So Polymer, HTML5, Google likes that stuff?
Google loves that stuff.
Yeah. It's good for the web. Do you want us to maybe give like a quick summary of like what Polymer is, what web components are?
That would be perfect.
Okay. So web components are a set of a new emerging standards. So basically trying to come up with a really good, strong component model for the web so that developers can build widgets, bits of UI, even non-visual components, and have them have really strong encapsulation, good scoping for things like styles and markup. And so there's about 4 different specifications that make up web components. Each one by itself, duff. When you combine them all together, you get this like really powerful component model. And Polymer is just a really opinionated way to work with web components. So one thing that it does is it adds polyfill support for any of the missing web component specifications. But the other thing that it does, and sort of the more important thing that we think that it does, is it just gives you a good direction for how you should build and create your web components. So there's a lot of developer sugaring that we've added to Polymer just to make it a lot faster and a lot easier to get up and running, creating components, creating data bindings with them, loading them into your page, things like that. So from the really like high level, that's kind of those two technologies.
Cool. Are people out there actually using stuff right now? Is Google using it?
Yeah, so we've been using it. The Polymer website is built using Polymer. ChromeStatus.com is built using it. There's a site that actually just went up recently from Michael Blay, the creator of DivShot, called ele.io, ele.io, which is sort of like a JS bin type site, but it's written and created using Polymer elements. And probably the biggest thing is the material design stuff that we were showing at Google I/O is built using Polymer and web components. So that's all open source right now. If people want to go to like the Polymer website or go to our GitHub org, they can actually grab those elements and start playing with them. And also Salesforce. Salesforce has been building stuff with Polymer as well.
Yeah, just to say, don't forget Salesforce. They got really stoked about web components and started kind of moving their mobile SDK to have an offering with Polymer components because it really makes sense for their developers. Also, a little known fact, I think I showed this in one of my I/O presentation, was that the Chrome OS keyboard and the media player in Chrome OS are actually also built using Polymer, which is kind of cool. So I like to think of it anytime you're chilling on Chrome OS and you're, listening to your tunes or watching a movie or something, you're doing it through web components.
So I have a question about web components in general. It seems like it's unclear in my mind what part of web components are based on a spec and what part are just people implementing stuff. I know that various frameworks do different kind of component-y things. It seems like kind of a vague term to me, at least. Can you clear up some of that, or is it still just pretty up in the air?
So I can take a stab at this one. So I've been in kind of when Polymer started, which is now over 2 years ago at this point. But the longer term initiative here is through all the specifications, the web component APIs. So this has been in the works for over 4 years now. The Chrome team and members of the Blink team have been working in the standards bodies, working with Mozilla and others on trying to get just kind of identifying the necessary APIs that we were missing from the web in order to build just really complex, really awesome applications. Just general APIs for productivity. That's what really web components is all about. And if we get nothing more out of it than that, it's a win. I mean, I think Rob, myself, anybody who's touched this stuff so far can kind of contest that it's very, very valuable and it makes your life very productive. So there's a lot of these lower level primitives that they put in just to make, things that other frameworks, for instance, have implemented. So they've implemented this stuff in JavaScript, but hey, why not add something that everybody's doing directly to the browser, right? This is very akin to something like document query selector or some of these other APIs that jQuery made popular. And now, of course, those are built into JavaScript. They're built into the browser, so everybody can take advantage of them natively. So there's all that specification work, and like Rob said, there's the 4 main specs, the templates, the shadow DOM, there's custom elements, and what am I forgetting? And HTML imports.
HTML imports, yeah.
Yeah, that's the one everybody kind of takes for granted because it's by far probably the easiest, but it's also probably one of the most important ones. So there's those 4 main specs and kind of other interesting players are things like object.observe, right? These are primitives that are landing that aren't really under this web components umbrella term. I kind of think of web components as sort of the new HTML5 term where it's this kind of catch all of all this new stuff in the platform. But the 4 primary ones are the template, shadow DOM, custom elements.
And HTML imports.
And HTML imports.
You forgot it right after saying everybody forgets it.
Yeah.
Yeah, so that's the big difference, I guess, is that we have those 4 specs, and you can go and you can actually read through the specification. All 4 of the specs that Eric listed are now actual features that are shipping in Chrome. They're just part of the platform. And that's all stuff that, other frameworks have had to invent for themselves. And now it's just there. They can just leverage it natively, which means they can write way less code. They can take a lot of code out of their code base. And hopefully, it can make things, a bit speedier for them as well, because they're not having to build this whole universe on top of a browser.
What about other browsers and how standardized are those specs? And are the specs recognized as standards yet?
Yes. So templates has been there the longest. That one's been, now it's in Firefox, it's in Chrome. Safari is working on it it's in the WebKit nightly build. So that one's been around for now maybe a year or two. Custom elements went to last call recently, earlier this year. Shadow DOM is still evolving, but it's getting to the point where now it's pretty stable. Obviously, Chrome has stable Shadow DOM. So we're probably not going to iterate on it too quickly from there, but we'll adopt any changes the standards committees come up with. And then HTML imports is still, forget exactly where it is, but in the standards process, but it's also pretty well defined at this point.
Okay, time for a confession. I've heard the word Shadow DOM 1,000 times. I'm a professional web developer. I don't know what Shadow DOM means.
It's the only thing I know out of everything that you said, but it's also got the coolest name. It sounds like something out of an anime.
Yeah.
Look out for the Shadow
I'll take
DOM!
this one.
It's the most
Jameson.
effectively named.
The Shadow DOM is when you salt your DOM and then crypt it with an MD5 cell.
Is it like the dark web?
It is. It's like the dark matter of the web, yeah. You can't see it, but it's there. Exerting force.
It serves a purpose, yeah.
So the Shadow DOM, in like a nutshell, is basically like a separate little document tree that you can put DOM into. You can put, HTML markup and CSS in there. And when it all gets composed together, that stuff's going to render, but it is protected from the parent document. So someone is not going to, like if someone writes like a CSS selector or something like that, it's not going to affect the DOM nodes that are inside of that tree. So it gives you CSS scoping. If someone writes JavaScript, if they're using jQuery and they're like, oh, I want every paragraph on the page, it's not going to find a p tag that's in that separate little tree because it's encapsulated in there. So the really best example is if you look at the video element, and when you use a video element and you give it a controls attribute, you see all these little controls at the bottom. You see like a play button and pause and scrubbers and things like that. But like you don't have to write any markup to make those controls show up, right? You just add that attribute and they kind of magically appear. And so if you go into the Chrome DevTools and you turn on Show User Agent Shadow DOM, you can actually inspect that element and you can open it. And what you'll see in there is this little it's like a hash symbol and it says shadow root. It's kind of like a little document fragment. And inside of there, you'll see that those controls are actually just like divs and inputs and things like that. But they've been sort of like hidden from you in this little tree. So the nice thing about that is it lets you make these components, which you can compose together very nicely because they're not like bumping into each other. Their styles are not colliding. Their markup's not all over the place. It's kind of like a big composability feature. And you've actually been using it all along and you didn't know it because input and text area and video, these all use Shadow DOM.
That's pretty cool.
The way I think of it too is like it's all about scoping with web components. It's scoping the problem. It's scoping how we develop. It's kind of like narrowing your field of what you're trying to achieve. Like let's define that functionality. Let's wrap it in a component, make that thing reusable. And so like Rob said, it's for the first time we can actually scope CSS. Like we don't have to have this global, style sheet that just kind of we add to over time. Hopefully our, styles will just kind of work out in our app. We can actually just define like that stuff inside of the component and it's just scoped to the component by default. So you have some guarantees now as a developer that, your CSS isn't going to leak out. And, if somebody's embedding your component, that stuff's not going to actually leak in and affect how your component looks because you've spent a lot of time making it look awesome. So you don't want that to be mucked with. So it's really cool. It's the features, again, it's all about scoping. And this is something that Polymer uses out of the box. We just say, hey, we think it's really valuable to have DOM and CSS scoping where everything is self-contained. So by default, when you create something in Polymer, you're creating it using Shadow DOM. So you get those features for free.
So, I'm so used to the workflow of working with the DOM as a tree. It seems like if everything is made using the Shadow DOM, then it's all going to be one level deep and you won't be able to dig down into stuff. Is that a problem that comes up or does that even make sense?
It does make sense, yeah. We actually have examples of this where some of our demo applications are like the entire application is, your HTML tag, your body tag, and inside of that you just have one element. You have app-my awesome app maker or something. Like this is the name of the tag that you've created. So like your entire app is one single HTML tag, which is kind of crazy. But it just goes to show you how far you can actually push that stuff. The example that I usually like to show and kind of explain to people why Shadow DOM is important is because if you take a look at like Gmail, for instance, in the dev tools and you inspect the markup that Gmail renders, this is a really complex application. But if you look at it, it's all constructed using divs and, just a bunch of gobbledygook. So it's actually, as a developer, like it's hard to come in there, maintain that code, know what's going on. And ultimately, a lot of that stuff is just implementation details of Gmail, right? And so that's what Shadow DOM brings to the table is it's giving developers now the opportunity to hide some of the implementation details that aren't necessary for users or other developers, I would say, of their app or their page to actually look into. But having said that, this is the web. You can poke around. As Rob said, you can turn on the dev tools and you can drill into stuff now. So as a developer, you have full control. If you want to, you can muck with someone's Shadow DOM. You can use the document query selector to get inside. You can edit things and change things in CSS. So we didn't want to remove that ability because that's actually, hackability of the web is actually really important. A lot of us grew up on learned web development just by viewing source, right? We want to preserve that sort of tradition and being able to hack and change things if you need to. So by default, it gives you some guarantees and some encapsulation and scoping principles, but you're totally, as a developer, as a user of someone else's component, if you need extra manpower, you can totally drill in and do something to your liking.
Yeah, one way that it was explained to me, which I actually really like, was by Scott Miles, who's kind of like one of the architects of Polymer. And he was like, think about like a program that you might write in C++ or Java, where you've always got a main function that just like kicks off the entire program. And, the first thing you learn is don't put your entire program in the main function, right? Like break it into objects and have things that are kind of like local to those objects. And you can sort of think of Shadow DOM in a very similar way. For basically like most of the history of the web, index.html has kind of been like the main function for like your website or your web app, if you want to think of it that way. And we've just been throwing everything in there. Like your entire site goes in index.html. There's no sort of like bundling up and scoping of these things. And so Shadow DOM lets you kind of think about your page more as objects. And that can be really useful for just like your mental model.
That's really cool. I'm glad I know what Shadow DOM is now.
Now everyone's an expert. Yay.
It's half the battle.
Yep, it's like dark matter.
So
got it.
I've got a question. I mean, I don't understand how web components are going to be efficient in terms of the network traffic, because I'm going to just include a bunch of links to components on other places, and they're all going to pull down their own CSS and scripts and blah. So how is that efficient? Because normally today we go through a build process to try and, get everything into one JavaScript or a few JavaScript files and a handful of CSS files. How is web components a thing that can be efficient?
It seems like you're kind of counting on HTTP 2.0 at that point, right? If you're actually pulling them down from different places on the network.
Yeah, one thing that we have, you're absolutely right. So the notion here is that with HTML imports, and using web components, you can load in someone else's component, and maybe that component that you're loading, loads 10 other components or, uses 10 other things that it needs to get its job done. And so I think the way I think of this is that first and foremost, like web components makes us more efficient as web developers and we're more productive. And then web best practices still apply. So as we have developed tools over the years for, just regular application development, we're also going to need tools for this world of web components to learn things like what an HTML import is and how to deal with it. So we actually wrote a tool. It's called Vulcanize. I forget the actual definition on Wikipedia, but it has something to do with Polymer. It's like the process of polymerization or something. So it was named kind of appropriately. But it's pretty cool. It's this little node script that you can run. You can also use it with Grunt or Gulp. And it's essentially our recommended build tool for kind of crushing and concatenating a list of HTML imports into the dependency tree. So you can tell it to do things like, hey, I want to have a single HTML import. And so you can reduce 100 network requests if that's what your app is doing into a single one. It can do things like inline CSS and minify HTML and CSS. And it can also deal with things like CSP. So if you're in a CSP environment like Chrome apps or something, you can separate out your JavaScript. So yeah, really cool tool. And it's definitely like right now, it's tooling for web components is still very new. We're only a couple of years into this. And as of, Chrome 36 this year at Google I/O, this is the first version where there's native stuff with the native APIs in all the browsers. So as people start to discover this and need, additional tools for their workflow, I think you're going to see some really cool stuff come from the community.
You said CSP back there. Can you define that?
Yeah, so CSP, Content Security Policy, is, it's basically, for those that don't know, Chrome apps is a good example where this is in use. So you can implement this on your server just for extra security measures to prevent things like XSS attacks. But Chrome apps by default, if you're building one of those, it actually has this built into the system. So we want to make it, the application that a developer creates very secure by default. And so with that comes restrictions on what you can do. You, for instance, can't have inline script tags. Now that's just a no-no in CSP world. So you have to reference an external script or, source equals instead of inlining a script as the one example.
So Vulcanize, it's a Polymer build or it's a web components build or it's a build for both?
Yeah, good question. So right now it's evolved to be more of a Polymer tool just because we have sort of this declarative way to create custom components with the Polymer-element. And we have, some other Polymer features that it knows about that aren't part of the web component standards. But I think what's going to happen over time is that this will evolve, hopefully, by means of the Polymer engineering team doing it, or by means of the community actually, helping out, is to adapt it into a generic build tool for web components. I think that's really, really awesome, and definitely needs to happen. Biggest thing that it does is just, it's kind of simple what it does. It just traverses the imports in your file that you load and just goes off and discovers those and creates them and concatenates them in one file. So it's pretty trivial what it does, but ultimately it's a huge performance boost. And if you're worried about network requests, that's absolutely the way to go.
Are you guys gonna be mad if I ask you a question from Angular land and you guys can talk to me about it in web component land? Is that cool?
Yeah, that's cool.
So one of the things I like about Angular is you can have these things called directives, which are kind of like new attributes that HTML didn't used to support, right? Mm-hmm. Well, and I like that I can take one element, some random div, and I can put a directive on it and then it does a new thing that it didn't used to do. But I also like that I can put two directives on the same div, and now it does two things it didn't used to do. So they're really composable. If you kind of like modularize them into what you want them to do, you can kind of plug and play them and you get the, both effects on one element.
Right.
Is there a way to do this like with Polymer or with web components? I'm not seeing one. Can you guys talk about that?
Yeah, sure. So there's not a direct comparison for like annotating an element with two different features as you described. That's actually something what we typically do for something like this is you create two components, each for those, for each purpose, and then you compose them together inside of another component. And so one thing that custom elements does give us now is this common sort of way to extend other people's work. So we don't have to rethink about, using some framework API to extend an element or a component. There's actually a standard way with custom elements to do that now. So if you wanted to, you could easily create this new element that has both of those features together and that composes these elements together and these components together to have both of those features. So instead of annotating, you're working more at the component level and sort of composing. Right. There's also, there used to be a thing I'll just mention, there used to be this thing in this Shadow DOM spec, or one of the specs that was called decorators. And decorators actually, it was the ability to sort of annotate an element with CSS. It would say, hey, be this, fancy button or something. And it would inherit all this cool CSS and whatnot. That actually, it's kind of in a holding pattern. It's not going to really progress. I guess the browser engineers think it's just too impossible to implement and it's not going to be performant in any way. So we don't want that. Obviously, we don't want to introduce any, new APIs in the web that are just crap, especially now we're in this mobile world where everything has to be lightning fast. But yeah, that's where that is.
Gotcha.
I wanted to ask about the Polymer stuff that was announced at Google I/O. I didn't follow it super closely, but I gather there are a bunch of new components introduced, basically, right? Is that accurate?
Yeah. For a long time, we've been developing Polymer as sort of the sugaring library to make web component development really easy. But we also wanted to vend and create some really compelling components for people to just use. I think there's two kinds of developers in the world of web components in this new ecosystem. There's the kind that are going to author components, right? These are the really fancy, awesome library and UI frameworks out there that can create components that are really awesome for people to use. And then there's just your, regular web developer that wants to be, just drop something in on their page and have it start working. And so those are, your consumers of components. And there'll be two flavors. There'll be people that develop stuff and there'll be people that just consume stuff. So what we did was a while back, we started creating our core dash element set, which is essentially just a useful, collection of things you would normally do on the web. So there's a component for doing things like selection. So doing multi-select, collapsible widgets, things that, every UI framework out there does, but we wanted to show people how to do it in the world of web components and sort of how to structure these things and compose different elements together. And so that's been growing for a while. We probably, at the end of I/O last year, we started hitting that road pretty hard and creating a bunch of useful stuff. And that's, still continuing to evolve as we ourselves discover sort of the best practices of building applications based on components. And then at I/O this year, Rob can probably talk more about this. He's our design dude. But we launched and we talked about material design and sort of the UI portion of our component set, which is based on Google's material design. Rob, do you want to talk a little bit more about it?
Yes, the material design stuff it's kind of the core elements give you a really good base to build upon, and the material design stuff we want to have more of an opinionated look and feel to things. And in particular, we want to make sure that we have this really nice unified UI across all the different device platforms that are out there, right? Because as a web developer these days, building a website is no longer like, oh, it's got to work on, desktop and laptop and phone. Now there's like a bunch of different form factors for phones. There's TVs. Now we have wearables. And so the whole idea with material design has primarily been, let's make something that works good across all of these platforms. And the element set makes it really easy for you to just like drop these elements into your application and get up and running really fast. And so there's kind of this like really awesome power that comes from that, where as you're building something and you're like, maybe you're building like a mobile app and you're like, yeah, I want to have like a toolbar up here and I want some like content that scrolls underneath it. Just being able to like bolt together a couple elements makes you feel like you're using something that's kind of closer to like UIKit from iOS versus just like cobbling together a bunch of HTML and CSS. And I think that's really where we want to head with this, is we want to build these element sets that give developers the sense that they're working with like a really kind of like solid like SDK versus just like copy and pasting widgets all over the place.
Yeah, just to reiterate, like being able to just declare something on the page and start using it and not have to muck with, JavaScript or CSS is extremely powerful, and it just makes you, it starts you off at hero rather than zero. So, the CSS is all part of the element, right? The JavaScript is all part of the element's prototype. And so you just as a user, if you want to scaffold out a mobile application, you drop in a core toolbar, you drop in a material design scroller panel or something, and an app drawer that slides out. And all that stuff is again, just built into the elements. So you have to think about less when you're building with web components.
That sounds rad.
So here's a question I've got. With the web components, like what is the package manager for that going to look like? And what about server-side components? Because if we have a good like widget for adding a credit card, shouldn't we have some like super easy to add widget for into your node or whatever for the API for that?
So I can take the first half. The first half was like about package management, correct?
Yep.
The package manager that we're using right now is Bower, primarily because it's it's configurable, it's pretty easy to get set up with, and it's oriented towards front-end packages. And it does a really good job of making sure that when you're pulling down a dependency, that you're only pulling down that dependency one time. Basically, it's deduping things versus NPM, which is going to put the dependency into, over and over and over again into node modules folders, and then you're going to need to run like dedupe on that. So we've chosen Bower initially, not that we're ruling out NPM or anything like that. We're still definitely like interested in other package managers and how they can, work well with web components. We want to make sure that whatever we use is the best tool for developers. So yeah, we've initially focused on using Bower, but we're definitely open to like exploring other options if folks have like compelling reasons why they want to use something different.
Well, and this is one of those things too, like we mentioned, Vulkanize as a tool that's kind of come out of the need for something to have a build tool for web components. But yeah, maybe a new type of package manager is necessary for the world of web components too. Right now, Bower is sort of the new hotness for front-end development, but it's still pretty young. But there could be something in the future that, the Polymer team or, the web components ecosystem adopts just because it is built and suited more towards this component development. I think all tools today, as far as package managers for the web are a little bit different. They have their own strengths and weaknesses. But Bower just happened to be sort of the most closely aligned one that we needed at the point of, getting people up and running and installing stuff.
So I wanted to ask about the role of web components in existing frameworks. It seems like you kind of mentioned it already, but I think we could talk a little bit more about it. So especially stuff like React that's already component-ish. Do you see a future where the kind of state management stuff of React is all still around, but it uses web components underneath? Or do you think that these are like two separate evolutionary trees?
I think that could still exist for some things. Like, it depends on... The interesting thing is that web components open like a million doors. And so there's like a million ways to do things. But I think that one of the things that I've been looking at is Flux from the React team. Have you guys seen that?
Mm-hmm.
Yeah, and just starting to explore that and to see if Flux does a good job of handling kind of the cycle of how data flows into your elements, and then how it, once your element is ready to like respond to a change or something, how that flows back through the circle. And I think that perhaps something like that totally works with web components, because at that point you're just treating your component as just like a little view. But you can, if you want, go kind of more complex, and you can have, components that are like view controllers. You can have components that are managing the state of all of their children. Like, I've taken the React tutorial even and just rewritten that as Polymer elements just to see if I liked passing data around that way, and it totally works. But at that point, you're like sticking to a pattern versus something that's actually like built in directly. Like, React has this notion of state versus prop, and a Polymer element doesn't have anything like that. You're just sort of saying, I'm only going to send this data this one way. So I think you can do it really like anyway. I think that there will totally be room for all those approaches.
Yeah, I know, for instance, I know the Angular team, right, is really interested in some of the specifications and the lower level primitives. And so I think for 2.0, they're considering adding in, native support for things. Like when you create an Angular directive, maybe you're using the custom elements API under the hood. Or when you create a directive, you're using Shadow DOM to get some of its benefits like CSS scoping and DOM scoping. And so that's it's kind of the beauty of the whole system now is that it's at its lowest level. It's all just new stuff in the browser. So if you're a framework author, if you're a regular developer, like you can take advantage of that stuff and you can go low to the metal and touch the native APIs. React is an interesting one just because it completely bypasses any notion of DOM. So the browser's lowest level is the document object model. But what React does is actually creates a virtual DOM. So they say, hey, we're going to just bypass this completely and avoid it just because it is too clunky, it's too hard. And so they have their own system for dealing with that that pushes out changes. What Web Components is really doing is embracing that, embracing the DOM and saying, hey, we can add APIs that are actually, that are meaningful and usable and make this stuff fast.
I think Web Components adds more to the game as well, just as a standard and as an API. It's bringing things like scoped CSS that, whether you're in React or Angular or Ember or, jQuery even, you should be able to benefit from things like scoped CSS. So, the levels of how much Web Components benefits everyone, depends on what you're trying to do, but everyone should be able to use some part of the Web Component API if you need it.
Totally. Template is also a really good example. Just, it's a single new tag that you can drop in on your page and anything inside of it is just totally inert. So it's actually a true template. It's true templating in the DOM. So, if you're creating an application that uses HTML, it makes sense to scaffold out and create templates in HTML to do that. And so it's really cool because it has features like not making a network request. If you have an image in a template, it's not going to fire off that request until the developer actually activates that template. And this is really hard to do, just by polyfilling it in JavaScript. It's almost impossible to. And so this is kind of the hurdles that frameworks have had to go through over the years is to implement a lot of this, this heavy business logic themselves. And now they can just start using these native features for free and taking advantage of what they do.
You guys are deep into Web Components and you're very excited about them, and it's very easy to talk about all the awesome stuff they do. Are there any weaknesses or potential problems that come along with all these new APIs and with the idea of Web Components?
I think that the one thing that's really, really, really tough for a lot of folks is taking something that maybe worked in the world before Web Components and then trying to stuff it into a Web Component. And it's what I personally, as soon as I learned about Web Components, the first thing I did was I was like, great, I'm going to take Twitter Bootstrap and I'm going to shove it into a Web Component. And everyone has this first inclination because it makes so much sense. You're like, Bootstrap is components. I'm just going to make them into tags. But then you run into the fact that the Bootstrap style sheet is just one big long style sheet that was written assuming that it could touch every part of the document. And when you are suddenly scoping bits of the markup, scoping it so that the CSS can't reach it, the CSS would actually have to be in the Shadow DOM with it, and you would kind of have to write that element from the ground up. That's where people, I think, get really confused and really frustrated initially. And it feels like they're like, oh, why doesn't this just work? And it's well, it's a totally different model. And so there's a lot of stuff that we have right now, like jQuery plugins, things like Bootstrap Foundation, frameworks like that, that totally will work as Web Components, but there is going to have to be a time investment there to rebuild things as Web Components, leveraging the scoping and the encapsulation instead of trying to fight against it. So that seems to be one of the biggest hurdles that people run into for sure.
Yeah, I think my little spiel for this at I/O was, BCE, before the Common Era, but what it means now is before components existed. like Rob said, there's this time, before web components where everything was written to be like it was just this global context and you had complete control over the universe. But now, we have to get developers in this mental model of changing their views and changing from this global context to, again, like think about the problem that you're trying to solve and create a very specific component functionality for that problem. And that makes application development much, much easier too. We'll be able to scale our apps a lot better by reusing different chunks. So there's a lot of benefits there, but I totally agree with Rob. Like one of the biggest pain points we see today from folks is just, hey, can I use, insert library X or component framework Y inside of a web component? The answer is sometimes. The answer is, maybe not, because it just was built in this time before this stuff existed. The other thing that comes up a lot is, since this is a different way to think about building web apps, a lot of people come into components or play with Polymer for the first time, and they'll create, some really basic, trivial components. I think the kitten, X-kitten element that just renders a bunch of kittens right on the page is something that obviously is a toy. But I'm really interested in the proliferation of an ecosystem and actually growing this to be something that any web developer can take advantage of, right? I shouldn't have to reinvent the wheel every time I start an app. I can go get somebody else's awesome component they've created. That's probably not going to be an X-kitten element, but it could be, an awesome calendar widget or something. So that's what I'm super excited about, is just being able to not have to start from scratch each and every time I create something.
We're about out of time. Can I ask a couple Google I/O questions?
Sure.
Yeah, sure.
How long before and after I/O is life at Google not normal? Like, I know there's ramp up and there's ramp down, and I was at I/O and there was so much Dart and Polymer this year. It was like everywhere. So I'm imagining you guys had all the Chrome dev evangelists were like going insane. So how long is life not normal? Are you guys back to normal yet, or yeah, that's what I'm asking.
I'm still tired personally. Rob,
yeah, I am also a little worn out still. Leading up to I/O is kind of interesting because I don't know if people realize just how much time we spend on it, how much work goes into it, how much prep there is. I mean, everyone's rehearsing their talks multiple times, writing their decks, getting them approved, trying to figure out what your messaging is going to be and your demos and your examples. And it's huge. It's like a few months, of just that's it. And it's like a meteor or something heading towards the Earth, and you sort of see it up in the night sky, and it starts to get bigger and bigger and brighter very slowly until it's all you can see. And then it just happens, and it's like a big blur. And then afterwards, everyone just goes on vacation. Everyone's done.
That sounds a lot like
people are still on
Doomsday.
vacation too.
Yeah. People are still taking vacation right now. They're just ugh, I'm out.
So the meteor approaches, hits, everyone dies.
That's right. And then they come back to life as zombies.
There we go.
I think, to be completely honest too, I mean, for certain groups Rob and I, we don't really ramp up on I/O until, early next year. But there's teams now that are planning the next I/O, immediately after the previous one just wrapped up. So it's a crazy, huge production, and how it all comes together is still mind-boggling to me. I've been at Google for a while now. I've been at every I/O, and it's amazing that it all comes together, and we figure out the messaging, things actually launch when they're supposed to, and all that jazz. But it's an exciting time. I think now, the aftermath of I/O is usually where you kind of pick up the pieces and decide the polish, for instance. The Polymer team, we're just kind of figuring out, okay, we had all this, great momentum at I/O. We got a lot of great developer feedback. How do we take that and now do something really interesting with it? So you'll see us over the next couple of months kind of polish what we have, maybe build a few new tools, the things that people are wanting from us. We have now time again to do them, instead of ramping up and getting crazy during I/O time.
Yeah, the other interesting thing is how it changes. I think before I/O, the team, we had, people who were interested in the project, and we had people filing issues and things like that. But it was a big announcement at I/O, material design being built with Polymer, and we had all these sessions. And so now, even the way the team works, we have to adapt to this increased interest, the vast number of GitHub issues that are flowing in, people asking questions on the mailing list, people who are brand new to Polymer. And that's a big task, maintaining all that support while at the same time, as Eric was pointing out, continuing to like polish the elements. The nice thing about it though is that we benefit so much from the open source community. Like that Polymer as an open source project is a huge advantage because developers come and they're like, this thing should work this way. Here's a PR, here's a pull request to like patch it up. That's awesome. Like that's amazing that people spend their time working on it and making it better for everybody.
Yeah, we love you guys.
Yeah, you guys did great. I was really impressed. I actually got lucky. I got to go to a lunch with the Chrome DevRels. It was pretty cool. So I think I saw both Eric and Rob there.
Nice.
Yeah, you're around.
I think we do need to ask the only question that anybody cares about, and that is, can you get me a ticket to Google I/O?
Will Joe Eames be at the next I/O?
You got to build gas and Polymer. That's what you got to do.
Yeah.
There we go. Yeah, then we'll put you on stage. But then you have to speak, and that's always nerve-wracking.
I was speaking on behalf of all of our listeners. They all want to know how they can get a ticket.
They all have to build awesome stuff with Polymer.
We're going to have 20,000 Polymer components built.
Let's do it.
I mean, every day they change it too a little bit, the registration. So I know like this past year they put in a couple of Easter eggs here and there in like documentation and SDKs. I think we'll do more of that in the future because it does encourage, the developer community to get involved and try to, if you're using our stuff, you're on our documentation, like you should be almost rewarded for that and get a ticket to I/O. So we'll see what they do next year. I have no idea. That's obviously out of our hands and something that marketing does. But if I had my way, I would let everyone into I/O.
You're so nice.
Thanks, man.
So I do wonder, though, do these web components affect SEO?
Good question. We actually have, this has come up a lot because when people hear Shadow DOM and they think everything's hidden away, right? Is the search engine going to be able to index that stuff? And so right now we're in this world of basically just JavaScript polyfills. So in any browser except Chrome that has all the native stuff, you're going to get essentially just a JavaScript polyfill for Shadow DOM. And so what happens is it'll just output DOM as it normally would in a web application. So any search engine that, understands how to run JavaScript or indexes that stuff, indexes a dynamic application, will be able to work, pretty well with that. And I think Google actually, we just made an announcement recently, sometime earlier this year, maybe right before I/O, that Google is, a little bit smarter than it used to be as far as like understanding JavaScript applications and be able to index dynamic content like that without much effort on the developer's point of view. As we move to a world of like native, Shadow DOM, where whatever thing Google search is running, it'll be one of these things that search engines will just have to adapt to. Again, this is new for web developers, but it's also new for the whole spectrum. If you have things in Shadow DOM at some point, if your search engine understands, the entire rendered tree, the composed DOM tree as it should, then they'll just have to adapt as developers kind of build apps on top of this stuff. So we have a FAQ entry on this if you guys are interested, someplace in polymerproject.org that kind of goes into a little more detail here, but
one thing that I want to add to that is your components, typically the content that goes inside of them, that content, like, if let's imagine it's like a blog post or something like that, right? All the text content of your blog post, that is not going to be in the Shadow DOM. That's going to be in the light DOM, like kind of in between your custom element tags. And so even if the like crawler or whatever, I'm thinking of something, maybe if there's search engines out there that like don't run JavaScript, right? So even if that crawler can't run JavaScript, it should still be able to just see that content and be able to index that as just like text inside of like an HTML unknown element or something like that. So that's kind of like a best practice that, you shouldn't be shoving, like there's content that you want to be indexed, make sure that is like in the light DOM so it's readable easily.
Yeah, that's a really good point, Rob. I think Shadow DOM, definitely that's your implementation detail. Your important stuff should be surfaced to, the outside world. I think in Shadow DOM it's called like insertion points. You can render things from the user's world inside of the index.html page into your Shadow DOM at very specific locations. I think Angular has a feature like this. It's called like transclusion or something like that. But it's a very similar notion where you take and you reproject content from one space into the other, and it's a rendering thing. That's all it is. But as Rob said, like if you have links, if you have important text, like there's no reason that shouldn't live in the main document.
So I'm sorry, did I miss the coining of the term light DOM?
I think that, yeah.
It's like an unofficial term.
Yeah.
Like, I'm imagining some kind of future religion, right?
It is fun to imagine the light DOM versus the shadow DOM.
Yeah.
It's very Star Warsy, yeah.
Yeah, is there other forms of the DOM? And, like, do midi-chlorians matter?
They always matter, always.
And if one's the light DOM and one is the shadow DOM, then what is casting the shadow DOM? Between the light DOM and the shadow DOM.
The browser, I don't know. Yeah, this is actually, it's a really good point because it's not an official, if you go look at the shadow DOM specification, you won't see the term light DOM in there. But it's kind of this loose term that, the Polymer team and members of the Chrome team have kind of come up with to describe these two different kind of render trees. There's all the stuff that the user has, right? A user component can put, other elements, a span, a div, an H1 inside of your element. So a classic example is like a form tag, right? Just your standard HTML form tag, where you can put a bunch of elements inside of it, right? A select, an input, different tags. And what you put inside of that element actually matters, right? The form tag understands to do something interesting with those tags, those very particular tags you put inside. And so what a web component can do using shadow DOM and insertion points is say, I want to render the stuff from the light DOM, the user world, into these placeholders in my shadow DOM. And so you can do things like, you can create a component that renders a tab strip and take someone's H1, tag and put it at a very specific location, style it in a particular way to look like a tab, and take their content, maybe it's a div or a paragraph tag, and render that at a specific location inside of your shadow DOM. So it's pretty cool. It's very powerful, and it's super amazing when you start to compose a lot of these elements together. They become useful in certain contexts.
Cool. What do you guys see as the future of web components and Polymer?
I personally see you take these components, you build a better platform for developers to build upon for both like UI stuff and non-visual stuff. But, thinking just in terms of UI, I really, really, really like the idea of a version of HTML that is very like app centric and is kind of more like UI kit, where you have these primitives that you can build that help you create great like multi-device experiences. And right now, so much of HTML is document centric. You've got like headers and paragraphs and things like that. And we're trying to give you elements that are like toolbars and menu buttons and things that you actually want to use in something that's more of an app and less of a page. And combining that with new technologies like Service Worker, which we haven't really talked about today, but Service Worker basically gives you much better access to the caching mechanisms that the browser is using and network requests. And I kind of see this world where you can build these really powerful multi-device apps using web components, using Service Worker to give you good offline support. I don't know, that's just like the web of the future in my mind. That's where it's all headed.
Yeah, I think there's a lot of opportunity to take some of the existing clunky APIs in the web and make components out of them. So, IndexedDB is a really good example of just a really powerful low-level API for offline, but there's no reason users should have to ever touch the grossness that it is, right? You should be able to write a web component that makes it a little nicer and to be able to use, compose and use inside of other components if they need offline functionality. We get a lot of questions too, like, hey, how do I do testing with web components? How do I do routing with web components? And these are things that are totally solvable. We just need to show people kind of the path forward and how to componentize, if you will, that API or that library. So coming up with best practices for that, kind of fleshing out how to create an end-to-end application on top of components is kind of what I think we're going to spend a couple months on.
Awesome. For people that want to learn web components and Polymer, do you guys have favorite resources that are out there for people?
I love Eric Bidelman's talks.
I love Rob Dotson's talks.
And Matt McNulty's talks even. Yeah, the talks I think are a good place to start because they'll give you like a quick, if you just Google on YouTube, you look up like Eric Bidelman, Google I/O. Like Eric's talk at I/O was a great high-level introduction to not only web components but Polymer as well. And then hit up the Polymer website. We have a section there called Platform, which is dedicated to explaining the actual kind of like web component bits. We also then have the majority of the site, which is explaining Polymer itself. And HTML5 Rocks also has a bunch of great articles which cover web components specifically, like the actual standards there. So yeah, I mean, my personal path to learning them was to kind of understand web components first, just because I wanted to know, I didn't want it to seem like magic was happening that I didn't know about. I wanted to know approximately like what everything did. And then I started using Polymer because it just made me much faster when I'm developing components.
Yeah, I mean, it's good to know those primitives too, because like we've been trying to talk about for a long time, and Polymer is based off of all these standards. So it's good to understand the features that are brought to the table by things like Shadow DOM, and just to show, like, if you read the Polymer docs and you see, all the features that we're using for like CSS, for instance, they're all just the native Shadow DOM stuff. We're just leveraging them. We're helping developers build web components using that technology. So it's cool to understand as a developer what's available to you. If you don't want to use Polymer, you don't have to. We just make it easier to get up and running. The other thing I'll say about resources on the web and Rob can probably attest to this as he was ramping up on stuff, is that it's changed so much, even within the past 6 months to a year, that a lot of stuff out there is slightly outdated or slightly stale. So as you're
my blog included.
All right, Rob's going to take an action item to update his blog when this is done.
Yes.
But it's tough because Shadow DOM in particular, it's such this gnarly new API that has changed, and particularly the styling and stuff, the styling features, that a lot of stuff that was written is changed a little bit. So if you want the most up-to-date, check out the HTML5 Rocks articles. We try to keep those updated. Polymer's got some stuff on the general web components APIs, but it's mostly, centered around how to build apps with Polymer, and sort of it discusses the web component features in the context of Polymer. But those two are good, and then any presentations that are mostly within the past 6 months will probably be pretty good.
All right, Aaron, what are your picks?
All right, I've only got one pick this week. I'm sorry. I'm reading this series of books. I know I do books every week. I'm sorry. I do about one a week because I have like a 35-minute commute each way. So I'm doing books. I don't talk about the crappy ones. I only bring the good ones here. So the series I'm doing right now, it's awesome. It's called the Iron Druid Chronicles. And it's a 9-part series, and it's so good. I know I picked this last week, but I'm picking the next one in the series. It's called Tricked. It was really good. So if you haven't read Tricked, go ahead, read it. It's a really, really, really good book. And they're not super long reads. They're like 8-10-hour books. So anyway, yeah, that's my pick.
Cool. Jameson, what are your picks?
3 picks. Last week I was at the International, which is a tournament for Dota 2, which is a video game, which makes me the coolest person on this podcast, I'm pretty sure. And it was amazing. So my pick is the International. It was in the Key Arena in Seattle. 10,000 people all watching some people play video games, yelling at the same time was pretty fun. My next pick is a presentation that someone gave called The Unreasonable Effectiveness of Dynamic Typing. I've been kind of thinking out loud about static versus dynamic type systems, and I don't have a ton of experience with static type systems. So I'm trying to figure out the use cases, I guess, and the trade-offs between them. And this is a really good talk that reviews some of the research that's been done. And the talk admits that there hasn't been hardly any research, considering this is like $1 trillion field, and this is kind of a big deal in that field. But the small amount of research that has been done seems to suggest that it's faster to develop programs in dynamically typed languages, and the type systems only save you from a very small percentage of bugs. So it's actually faster to debug them as well. So I thought that was interesting. And then the last pick is a website called Fit Men Cook, which sounds like it could be kind of racy.
They do.
It's actually just recipes. I've been trying to eat healthier, and I'm really bad at thinking about what to create as food in the abstract. So I need a recipe. It's just a good source of recipes for people trying to eat healthy. Those are my picks.
Awesome. Joe, what are your picks?
I'm going to make just a couple of picks here. The first pick is going to be the Toastmasters organization, which is all about helping you be a more effective presenter and organizer. And I've been attending a local Toastmaster meeting for a while now and really enjoying it and finding a lot of value in working on my presentation skills. So I'm going to pick the Toastmasters organization for my first pick. And the second one is going to be a card game called Villages, which just recently had its party. It successfully funded on a Kickstarter. They just got everything printed, and they did a party at a local game store, because the guy who did it is a local, to launch the game officially, even though he's had versions of it out since 2011. But it's a kind of a trick-taking game. You lay down 3 cards at a time, but it's all played out like you're building villages with knights and dragons and all kinds of things. And it's strategic, but has luck to it, and it's really cool pixel art. And a very fun game to play. It plays 2 to 5 players. Pretty cheap. It's like $20. Awesome game. Really enjoyed it. So that'll be my second and last pick. Oh, wait. No, I have a third pick. I'm picking ahead because by the time this comes out, this movie will have been out for a few days, but I'm going to pick Guardians of the Galaxy. I haven't seen it yet. I have tickets to go see it in 2 days.
Did you love it?
Opening night. No, I haven't seen it yet.
No, but when it comes out, you'll have seen it. Did you love
it? Yes. I loved it. I loved it.
Awesome.
And if I hated it, then we'll have to edit this.
It's a ringing recommendation right there.
Yes. I'm so excited. Like on Rotten Tomatoes, it's like getting like 97% out of reviewers, which is just nuts. And I'm sure I'm going to love it. So I'm going to say I loved it. And if I didn't love it, then I'll have to retract that statement next week.
You know how much grief I get when I pick stuff that I haven't seen or used?
Well, if you pick stuff you haven't seen or used, but that someone has paid you to pick, you'd probably get more grief.
That's true. I don't do that.
Marvel so actually paid me for that endorsement. He sent me a check for 16 cents.
Wow.
Worth it.
Awesome. Well, I've spent all day today at the Less Money, which is an online training conference, Google Hangout thing, and it's been really good. We're talking about building freelance businesses and basically moving up from just me to being an agency. So it's been really good. And that's really the only pick I have, so I'll pick that. I guess I can pick the other product that those guys have. It's Less Accounting, and that's what I use to do my books for my business. And they told me that just last week they put in a budgeting component, so I'm pretty excited about that. And those are my picks. Rob, what are your picks?
Okay, so I wanted to pick some music because I like to try to code to music, but sometimes it's really hard if the music has like too many words or anything like that. I can't like concentrate on what I'm like the code that I'm writing. So I'm going to pick this album called Cold Spring Faultless Youth by Mount Kimby, which is kind of, I don't know how to explain it. It's like some interesting electronic type music, but it's really good. It's really awesome. Definitely worth a listen. Let's see. Lately, last night I just finished this book called Flash Boys by Michael Lewis, which is about high-frequency trading. So it's like an explanation of Wall Street high-frequency trading, how it actually works, how the whole system is like kind of crazy and rigged, and sort of the endless pursuit of speed on Wall Street, like network speed, things like that, which is pretty interesting. And the last thing I'm going to pick, I'm kind of lame for picking this, but whatever, I'm actually excited about it, is the Samsung Gear Live, the actual like Android Wear watch. And I'm not picking this because I work at Google. I'm picking this because I actually think this thing rules. So I got one at Google I.O. And initially I was like, yeah, I don't know, it's like a smartwatch. Okay, I couldn't like figure out like how it really fit into my life. And the first few weeks that I wore it, I was kind of like not that into it. And I realized that I was just being overwhelmed by notifications. So I learned how to turn off all the notifications. So now it only shows me calendar notifications and Hangouts and IMs and the weather. And that's it. And it's awesome. Like if I'm just sitting somewhere, it'll just like vibrate and be like, oh, you got a meeting in 10 minutes. And then I can like run to the meeting or something, which is really, really, really handy.
I used to miss those meetings, but that watch helps me too.
Yeah, I really like this thing. Those are my picks.
Awesome. Eric, what are your picks?
My picks, so speaking of recipes, someone mentioned recipe, I've also gotten really into cooking lately, and I actually had a birthday recently, so my girlfriend took me to Vegas, we did the Vegas thing as a couple. It was actually really fun though, because we got to do things like Grand Canyon via a helicopter, and one of the dinners we went to was at Bobby Flay's restaurant. And if you guys have never like been to one of his restaurants, it's like totally awesome food for a reasonable price. But I actually ended up buying his cookbook, which is called Grill It, and so I've just been getting into that lately. Despite the fact that I work at Google and I get free food, like it's still nice to cook for yourself and know how to do that every once in a while. So like he basically uses 4 main ingredients. It's like honey, some kind of spice, some kind of, citrus, and some kind of meat. But they're all just like super easy to make, but they're actually really good. So I've been getting into that. My other pick just came down the wire actually. It landed in Chromium recently. It's basically a new API or an extension of the Scroll to API or Scroll into View API. So this is typically what, sites do. They'll do a smooth scroll effect, using JavaScript. But this is actually adding it natively to the browser now. So the browser can do things like optimize it, put it on its compositing thread, all that great stuff. So this is really nice because with one little API change, one addition, we get smooth scrolling that all these sites are doing anyway for free. Again, it's an extension of the web platform. So small change, but actually really big for performance. Those are my 2.
All right. Well, thanks for coming, guys. It was a great discussion and a lot of fun.
Cool. Thank you.
Thank you for having us.
Hosting and bandwidth provided by the Blue Box Group. Check them out at bluebox.net. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more. Do you wish you could be part of the discussion on JavaScript Jabber? Do you have a burning question for one of our guests? Now you can join the action at our membership forum. You can sign up at javascriptjabber.com/jabber, and there you can join discussions with the regular panelists and our guests.